Good afternoon. My name is Jessica Bennett, and today I will be discussing conducting a simple regression test. During this presentation, we will discuss three different simple regression tests. We will discuss, can we predict an individual's debt by knowing their income? Can we predict an individual's savings by knowing their income? Or can we predict an individual's portfolio value by knowing their savings? In each slide, we will discuss the null hypothesis, the alternative hypothesis, and each findings. Following these three tests, I will then discuss the annotated bibliography of Biddle.com Chapter 1, Intro to Correlation, Biochemia Media, the Chi-Square Test of Independence by Mary McCuff, and the regression analysis, How Do I Interpret R-Square and Assess the Goodness of Fit? Then we will discuss any takeaways and if there are any questions. The first test we conducted was, can we predict an individual's debt by knowing their income? The dependent variable is debt and the independent variable is income. The null hypothesis states the regression coefficient, or beta, is 0. The alternative hypothesis states the regression coefficient, or beta, is non-zero. A simple linear regression was conducted to determine whether we can predict an individual's debt by knowing their income. Because p-value is higher than alpha, we can't reject the null. O is in between the 95th percent confidence intervals, meaning this is not a significant value. The second test we conducted was, can we predict an individual's savings by knowing their income? The dependent variable is savings, the independent variable is income. The null hypothesis states the regression coefficient, beta, is 0, and the alternative hypothesis states the regression coefficient is non-zero. A simple linear regression was conducted to determine if we can predict an individual's savings by knowing their income. A statistically significant regression emerged. Beta equals 0.91, R squared equals 0.28, and P equals 0, therefore less than alpha. Because of this, the test rejected the null hypothesis and predicted that individual savings to increase when income increases. Furthermore, you can look that 0 does not fall within the 95th percentile of the confidence intervals, lending support to our prediction. The third test we conducted was, can we predict an individual's portfolio value by knowing their savings? The dependent variable is stock, and the independent variable is savings. The null hypothesis states the regression coefficient, or beta, is 0, and the regression coefficient, beta, is non-zero, is the alternative hypothesis. The linear regression was conducted to determine if we can predict an individual's portfolio value by knowing their income. A statistically significant regression emerged with beta equaling 0.28, R squared equaling 0.08, and P equaling 0. Because P is less than alpha, it shows us that we shall reject the null hypothesis, and we can then predict that the individual's portfolio value will increase when savings increases. Furthermore, if you look at the confidence interval, you see that 0 does not fall between the 95th percent. That lends support to our prediction. At this time, I will now conduct my annotated bibliography of 3 research articles I've read throughout the term. First will be Biddle.com Chapter 1, Intro to Correlation. For the first article, the key takeaways are correlation coefficient. Pearson's R is a tool that allows you to know if there's a relationship between two variables and how strong that relationship is. It uses scatter plots to assist with this determination. Recognizing the type of relationship also assists you. Negative relationship is if one variable increases, the other one decreases. A positive relationship is if one variable increases, the other one increases. and no relationship is if one variable increases, the other variable is unpredictable. It may increase or decrease. The second article is from Biochemia Media, The Chi-Square Test of Independence by Mary McCuff. In this article, it stated that the chi-square statistics is non-parametric designed to measure differences when the dependent variable is measured at a nominal level. Because of chi-squared is a significant stat, a strength stat must also be conducted, such as the Kramer's V. Some benefits of the chi-square test is ease to complete, the detailed information, and the flexibility. Limitations of the chi-square test include sample size requirements and the tendency of Kramer's V to produce low correlation measures for high significant results. The third article is Regression Analysis, How Do I Interpret R-Square and Assess the Goodness of Fit? For this article, it stated the goodness of fit is when the difference between the observed values and the model's predicted values are small and unbiased. R-squared, also known as a coefficient of determination, is how close the data is to the fitted regression line. R-squared equals explained variation divided by total variation. Limitations of R-squared are: you cannot determine if the coefficient estimate and predictions are biased. It does not indicate if regression model is inadequate or adequate. And then low values are not always good and high values are not always bad. So a few takeaways is the purpose of a simple linear regression test is to understand the relationship between two or more variables with the use of a straight line. R-squared is useful in understanding the relationships in regression analysis, and it measures the degree to which the data fits the regression line. Independent variable can also be referred to as the regressor or the predictor, and a dependent variable can also be referred to as the response. Are there any questions?